So, good morning students, how are you? I'm Francis sir and today we'll be studying standard 6 geography. Okay, so today we'll be studying the motions of the earth, which is the third chapter of this geography. Okay, so let's start. So, when we see this chapter's name, the motion of the earth. So, let's consider about the motion that is being occurred in the earth. So let's see, motion of the earth has been divided into two types. First one is the rotation and the second one is your revolution. Okay. So the revolution part, we will be seeing it in the next video. Today we will focus on rotation. Okay. So let's see what is rotation. Rotation of earth. Okay. So what's its definition? The continuous spinning of the earth on its axis. So when we are going through this definition, we need to understand what is an axis. What is an axis first? So whenever any object rotates, every body has a center line. Every body has a center line. For instance, I got a globe. So you can see this globe, I hope. Yes. You see that the places where these pins are joined here, it is just at the center point here also, center point here also, and these center points are joined to the midpoint, which is the midpoint of the whole sphere. So that line joining the midpoint of the whole sphere is called, that is called your axis. It straight away passes through the middle of the whole of sphere. So this is called what? Axis. This is called what? Axis. And when this axis, if an object starts to move about its axis like this, this motion, this type of motion, when it experiences about its axis, it is called your what? Rotation. What is called? Rotation. So the continuous spinning of the earth on its axis, it is called rotation. Okay. As we see here in this globe, if we consider that this has to be standing on an Earth's orbital plane, we see that if this is the axis, it is tilted. It is tilted at a certain angle from the orbital of the plane. Okay, orbital of Earth's plane. Okay, so that one. So it is inclined. So this inclination from the Earth's orbital is 66.5 degree. Whereas if we see it from the perpendicular from the orbital plane, vertical of the perpendicular means orbital plane, it is inclined at an angle of 23.5. How much? 23.5. So the angle between this vertical and this axis, it is your how much? 23.5. Okay, 23.5 degree. So that is what is called the inclination of the Earth's axis. Earth is not straight; it is inclined. It is inclined a bit according to the Earth's orbital plane. Okay, so Earth's axis is tilted at an angle of 23.5 from its vertical plane, as I told you, from the vertical. So this is your vertical direction and this is your axis. So this angle, angle between this vertical and this, it is how much? 23.5. Whereas this angle between this axis and that of this horizontal plane, no, this, you see my arm and you see the axis, this angle is almost 66.5 degree. Okay, this is the angle between the axis and the Earth's orbital plane. This is Earth's orbital plane and this is the axis. The angle is how much? 66.5 degree. Okay, so that was about the inclination of the Earth. So Earth's axis is tilted and we have two point of views, one from the vertical plane and one from the horizontal plane. So from the vertical plane it is 23.5 degree and from the horizontal plane it is 66.5 degree. Okay. So let us see some other important facts regarding the inclination of the Earth. The angle of inclination of the Earth's axis always remains the same. Means if it is inclined to the vertical at 23.5 degree, the whole year it rotates. The whole means, from the starting of the Earth till now or in future also, the angle of inclination of the Earth will be 23.5 degree from the vertical, or it will be 66.5 degree from the orbital plane. Okay, so that angle of inclination is not going to change. That angle of inclination is not going to change. Understood? So the angle of inclination of the earth always remains the same. Secondly, the inclination of the earth's axis never follows the change in position. That means, the earth orbits around the sun. The earth orbits around the sun. For instance, this is our earth, and let us consider this to be our sun. So this earth will be orbiting all around it. No, it will be orbiting all around it, orbiting all around it. Yes. So whatever the position of the earth may be, let it be here, let it be here, let it be here, or let it be here, in all the places its angle of inclination will be same. It won't change. It will be 23.5 degree from the vertical, and it will be 66.5 degree from the horizontal earth's orbital plane. Okay, so the angle of inclination does not change if the position of the earth during the. Okay, third one. At any point of the orbital plane, the axis is always parallel to its position to any other plane. This is very interesting. This is very interesting. Now it is like that, no? For example, this is the sun, and as I told you that this, its axis direction does not change. It is always in the same direction. Let this be sun and let this be. So how does it rotate? It revolves. When it revolves from this position to this position, you see that the direction of axis is in this way, and at this place also its direction will be in the same way, and at this place also its direction will be in the same way. So you see that its direction, let's see in this diagram. Okay, let's consider this to be sun, and let this be earth. So if this is the inclination of the earth, axis is inclined at this, this is the axis. When this earth will be here, again it will be in this way, the axis will be inclined in this way. If this, what do you say, if the earth is here, then also the axis will be inclined in this direction. If the earth is at this place, again it will be inclined in this way only. You see that if you see properly, all these directions of the axis, are parallel to each other, Understood? So at any point on the orbital plane, so what is orbital plane? It is the plane made by the orbit. If this is the orbit, so at any point in this orbital plane, wherever the earth is there, if we see the direction of the axis, it is always parallel to each other. Okay, this is what it is about, the important facts regarding the inclination of the earth. What were the three? Number one, it is 23.5 degree. Secondly, what? The angle of inclination does not change according to the position. What is third? And the third one is that the this axis, or this it is always parallel to its position to at other points on the orbital plane. At each places, what are they? They are parallel to each other. Okay, what are they? Parallel to each other. Okay, so now we go to the next topic, and the next topic is our effects of earth rotation. So we understood what is earth rotation. We understood that earth rotation, it is depending upon its axis, and so if it is so, then we need to know that what are the characteristics of axis. So we studied that axis is inclined at certain angle from the horizontal and from the vertical. Yes, we also studied that what are the some of the interesting facts regarding the inclination of the earth, and now we are to study what the effects of the earth's rotation. So the first effect of earth rotation is that rotation causes day and night. Yes, everybody knows, and you have known this from, I think, at least from standard 4. You have studied that occurrence of day and night is the result of the rotation of the earth. Okay. Second point is that this rotation of the earth causes the deflection in the direction of wind. Yes, this is one of the very important aspects. As what you do, it is a very simple experiment. You try this. Okay, what you do, you try this. You take a bucket. What you do, you take a bucket, fill the bucket with water, fill the bucket with water, fill the bucket with water, and in the water this, you keep a ball. What do you do? Keep an empty ball so that it floats, and what do? You just rotate the ball, rotate the ball. What you will see, the ball is rotating, but also the water around the ball is also rotating. This happens the same is the event in our earth also. Our earth is surrounded by atmosphere. What is this atmosphere? Atmosphere. Okay, this is our earth is surrounded by atmosphere. So when the earth rotates, it allows the atmosphere around it, the one which is attached to, this atmosphere is attached to the earth. So what does it allows this atmosphere to rotate along with it. A bit of rotation is imparted on this atmosphere. Therefore there is a bit of deflection in the direction of wind because of the rotation of the earth. Why? Because this characteristic of the earth rotation is a bit slightly imparted on the atmosphere of the earth. That is why the normal direction of wind is deflected, and generally this deflection is towards the right, towards the east, because earth rotates from west to east. Therefore the deflection of the wind is also in the direction of east. Understood? Generally. So it causes the deflection in the direction of the wind and ocean currents. Yes. Okay. Yes, it happens in ocean currents also, because ocean is also currented on the is also in contact with the earth. Therefore, because of earth rotation, the ocean currents are also deflected a bit. Okay. Now, second thing is that third point is that this rotation of the earth causes a centrifugal force to exist. Because of the earth's rotation, a centrifugal force is developed. What is the centrifugal force? First, you try to understand. Okay. Let us say that this is a circular object. Okay. This is a circular object. When it starts to rotate, each particle, each particle of earth experiences what? Centrifugal force. What? Centrifugal force. Okay. What does it experience? Centrifugal force. So centrifugal force, it is a force, in which, the particles of the body experience a force to move outside the direction of rotation. For example, if I rotate something, for example, you take a string, tie an object to it, and you start rotating. What happens that if you leave it, it straight away moves in a particular direction. For instance, we got this, okay, a key. Okay, let's see. So what I do, I start to rotate it. Okay, so the time I leave it, it will move in a straight way direction. Otherwise it would have rotated in the same place, but it does not happen. Why it starts to move away? It is because there is a movement, there is a direction. For example, what I said about rotation, you see, here is the center point and here is the object, and this object is rotating. So when I left the body, it will move always in this direction. So this is called your what? This experience is called your what? Centrifugal force. Okay. So this outward force is called what? Centrifugal force. Because of this centrifugal force, what happens is that the particles tends to move out. The particles tends to move out, and in the earth what happens? We have this type of shape. We have, sorry, my figure is not so absolute, but you understand that there is a bulging type of shape that has been developed on the earth. So therefore, the earth a bit broader at the equator, earth is a bit broader at the equator, whereas it is a bit of flattened at the poles. It is a bit flattened at the poles. It is a bit flattened at the poles. Understood? Like this. Just because of the centrifugal force acting, the shape of the earth has become in this way. Understood? Why the particles of the earth experience centrifugal force and they tend to move out and they are bulging and the earth is bulging. So these are the effects of the earth's rotation. Number one, day and night, very popular. Second, the deflection of the earth, it causes the deflection in the direction of wind and ocean current. This is also very important. And the third one is that it causes centrifugal force to come into act, because of which what happens, the earth's shape changed from a spherical to an orange shape. That means bulging at the equator and flattened at the tops. So this is what is about the rotation. So in the next video, we will be going for revolution. So very good day, go to the chapter, and we will see you in the next video. Good day.